Hello and welcome. In this video, we'll explore binary numbers, why they're used, base 10 versus base 2 number systems, and how to read binary numbers by converting them to decimal. The first thing you might be wondering is, what is binary? Binary is a numeric system that uses the digits 0 and 1 to represent all values. For example, we might represent the value 6 as 110, or we might represent the value 15 as 1111. It is essentially a different way of writing numbers. The number system most of us are familiar with is called the decimal number system. Within the decimal number system, any value can be represented by the digits 0 through 9. You might be asking, why don't computers just use the decimal number system, since most of us are more familiar with that? Well, in computing, there are a limited amount of ways to store information. Everything on the inside of your computer is controlled with electricity. In simple terms, electricity is either on or off. This can easily be represented with a 0 or a 1. Generally, 1 represents a higher voltage level, or on, while 0 represents low, or off. So when you see a series of zeros and ones, they really represent on or off signals within your computer. In reality, electrical signals are not perfect, so levels above a certain threshold will represent a 1, and levels below a certain threshold will represent a 0. Binary is important to learn because it is the way computers store and understand information. That explains what binary is and why we use it. But how can we read binary numbers? In order to understand binary, we'll first look at how the decimal system works. If you're like me, you've been using this system so long that it seems intuitive. Each number has different places. For example, in the number 283, you have the ones place, the tens place, and the hundreds place. This means that there are 2 100s, there are 8 10s, and there are 3 1s. When you add these all together, you get the final number 283. You might notice how as we move to the left, each place increases times 10. This means that these places can also be represented by a power of 10. Let's use the same number as an example. In the number 283, the threes place has a value of 10 to the power of 0. Anything to the power of 0 is 1. In the tens place, we have a value of 10 to the power of 1, which is 10. And in the hundreds place, we have a value of 10 squared, or 10 to the power of 2, which equals 100. Notice how for the rightmost value, we raise to a power of 0, and we increase the power by 1 for each place we move to the left. Decimal being a base 10 number system means two main things. It means that there are 10 digits to represent every number, and that each place has the value of a power of 10. So how does this relate to binary? Well, we already know that binary only uses two digits, 0 and 1, to represent any possible value. This means that binary is a base 2 number system. In practical application, this means that the value of each place, rather than being a power of 10, is a power of 2. Let's look at an example to better understand. Let's look at the example 1, 0, 1. We are going to do this exact same thing as we did with the decimal number system. Instead of raising 10 to a power, we're going to raise the number 2 to a power, since binary is a base 2 number system. So we'll start off with 2 to the power of 0 for the rightmost value. Next, 2 to the 1 power, since we increase by 1. Next, 2 to the power of 2. So to understand the value that the binary number 101 holds, we can simply multiply the digit in each place by the value that that place holds. For example, 1 times 2 to the power of 2 is equal to 4. We add this with the next place. 0 times 2 to the power of 1 is 0. And 1 times 2 to the power of 0 is 1. Final answer, 4 plus 0 plus 1 is equal to 5. So the binary number 1, 0, 1, which is written with a base of 2, since it is a base 2 number system, can be represented as 5 in the decimal number system. And when writing numbers in the decimal number system, especially as you start to work with other number systems, you should always write the base of 10. This is a fairly simple example, but it can also work for larger numbers. Let's try another example. Within the binary number system, some common terminology that you will run into is bits and bytes. A bit is 1 digit. A byte is 8 digits. Therefore, there are 8 bits in 1 byte. Let's try a number that is a byte long. So we are going to use 8 digits, or 8 bits. Let's use the number 1, 0, 1, 1, 0, 0, 1, 1. Now, as before, I'm first going to label each place's value. The rightmost place has a value of 2 to the power of 0. We then increase this power by 1 for each place we move toward the left. Now that we've labeled the value of each place, we can go ahead and convert this to decimal so that we can better understand the value that this number holds. We'll start off as before, multiplying the digit in each place by the value that that place holds. So we'll start off 1 by 2 to the power of 7 plus 0 times 2 to the power of 6 plus 1 times 2 to the power of 5 plus 1 times 2 to the power of 4 plus 0 times 2 to the power of 3 plus 0, 0 times 2 to the power of 2 plus 1 times 2 to the power of 1 plus 1 times 2 to the power of 0. Let's go ahead and convert these. 2 to the power of 7 is 128. 1 times 128 is 128. We can add our next place. 0 times anything is 0. Plus 1 times 2 to the power of 5. 2 to the power of 5 is 32. Plus 1 times 2 to the power of 4 would be 16 times 1, which is 16. Plus 0 times anything is 0. Plus 0 times anything is 0. Plus 1 times 2 to the power of 1 is 2. Plus 1 times 2 to the power of 0. Remember here that anything to the power of 0 is equal to 1, so this will equate to 1 times 1, which is 1. We have our final addition. We can go ahead and add all of these numbers up. I'm going to use a calculator to do that. There's no reason to overcomplicate things if you don't have to. So our final number is equal to 179. And since I converted this to decimal, I'm going to write a base of 10, so I don't lose track of that. Therefore, 1, 0, 1, 1, 0, 0, 1, 1 in binary is equal to 179 in decimal. For this video, we'll try one more example of a byte-long binary number, since that is the most common length of a number you will have to convert. I'm going to randomly choose the number 1, 1, 0, 1, 1, 1, 1, 1. Again, we are going to label the value of each place first so that we do not lose track. So we start with a base of 2, we raise this to the power of 0 for the rightmost value, and we increase by 1 for each place to the left we move. Now that we've labeled the value of each place, we can go ahead and begin our conversion. We use 1 times 2 to the power of 7 plus, you can put parentheses around these if it's easier to remember, plus 1 times 2 to the power of 6 plus 0 times 2 to the power of 5 plus 1 times 2 to the power of 4 plus 1 times 2 to the power of 3 plus 1 times 2 to the power of 2 almost running out of space here at the end, oops. So 2 to the power of 7 is 128. 1 times 2 to the power of 6. 2 to the power of 6 is 64. 1 times 64 is 64. We add our next value. 0 times 2 to the power of 5. 2 to the power of 5 is 32. However, we have a 0 here, so it's going to equate to 0. Plus 1 times 2 to the power of 4. 2 to the power of 4 is 16. Power of 4 is 16. 2 to the power of 3 is 8. 2 to the power of 2 is 4. 2 to the power of 1 is 2. And then 2 to the power of 0 is 1. Since we are multiplying all these by a 1, I did not say the times 1 part out loud, but you can infer that since these digits are a 1 and not a 0, we are counting their places. We did not count the place of 2 to the power of 5 because there is a 0 in that place. So we would multiply the value there by a 0, which gives us a 0. I'm going to use a calculator to add all these up. No need to make it unnecessarily complicated. And this will equal 223. I'm going to write the base 10 since we converted it to decimal. Therefore, the binary number 11011111 base 2 is equal to the decimal number 223, base 10. That's all for examples of conversion. Let's briefly review the topics we covered in this video. Why use binary? We use binary numbers because computers store information in simple on or off signals, which can be represented by zeros and ones. Base 10 versus base 2. Decimal is the notation most of us are familiar with. It uses 10 digits, 0 through 9, to represent any number. Decimal is therefore a base 10 number system. Binary uses only 2 digits, 0 and 1, to represent any number. Binary is therefore a base 2 number system. Finally, we covered conversion from binary to decimal, which will allow you to better read and understand binary numbers. The value of each place in a binary number is represented by a power of 2, since it is a base 2 number system. Thank you for watching this introduction to binary numbers. Feel free to leave questions, suggestions, or requests down below. This has been IT. I hope to see you in the next video.